Okay, just another example. It comes out, I think, fairly simply. You have a periodic function that exponentially approaches 1 on each interval. It starts at 0, exponentially approaches 1. Okay? And it achieves voltage B on each period. Maximum voltage is B. So we could write it like this. Well, this is a function it's going to be 1 minus e to the kt. And you can use your pre-calculus skills or other skills to see why it is, but it makes a certain amount of sense. If t equals 0, then you're going to get 1 minus 1, which is 0. Now, it's going to, e to the kt is going to approach 0, so f of t is going to approach 1, where k is a negative constant. Okay, we got to evaluate k. So f of 0 equals 0, and there it is. F of a equals b. Okay, so, and this is on just the first interval, because of course in the second interval everything shifts. So on this interval, t from 0 to a, this is what we have. Okay, well, f of a equals b. Okay, f of 0 equals 0 is taken care of already by just using coefficient of 1 in front of e to the kt. F of a equals b then says that 1 minus e to the k times a equals b. So e to the ak equals 1 minus b. So that k ak is a natural log of 1 minus b. K equals a over. Sorry. Still allergy season. Either that or I'm just deteriorating way faster than I hope. Okay. So we have k equals a natural log of 1 minus b over a. And we'll note that since b is between 0 and 1, 1 minus b is between 0 and 1. So the natural log is going to be a negative number. So k is going to be a negative constant. And we want to keep that in mind. Okay, so now what? So the Laplace transform of f of t is the integral from 0 to a being the period now. You know, our formula is integral from 0 to t, but it's not just a formula. We should understand it and understand that we're integrating over one period, over the very first period. Okay, so this would be 1 minus e to the kt, e to the negative ts, dt. I was putting a denominator in here, and the denominator, put that line up a little high. I'm going to extend it over here. Okay, the denominator is your 1 minus e to the minus as, same as in the preceding example. Well, this integral is really pretty simple. Simpler than the other one because you have an exponential either way. Okay, so just isolating the integral. Rewriting it. And then we can write this as two integrals, 0 to a e to the negative ts dt. Of course, that's just the integral of 1 dt. It's a Laplace transform of 1, which we know to be 1 over s, negative 1 over s, no 1 over s. I get messed up on the negative signs. I've got to do it in my head every time I do it because I don't bother memorizing things. Of course, now that my memory's getting a little fuzzy, that gets inconvenient. So maybe I ought to rethink that strategy. Anyhow, from then integral from 0 to a of e to the k minus t s dt, noting that k is a negative constant. And make sure I've got my signs right. We have a minus here, which gives us a minus, and that's straightforward. Okay, so it all looks pretty straightforward. And then this integral, well, okay, this integral is 1 over s, because it's negative e to the negative t over s. At 0, you're going to get 1, and since it's a negative integral and at 0 you get the, well, that's right. So this is going to be from your limit at 0, and your limit at a is going to be negative e to the negative as over s, and of course I could have factored that 1 minus s. Again, check my arithmetic here, my algebra. It's always worth checking. Okay, and then this is minus too many minus signs. You're going to get a minus sign from this. You let u equal k minus t, you're going to get the integral of u times negative dt, and that'll take care of this negative. So I believe it's going to be positive. Again, I'm doing this in my head and I'm skipping steps, so you know how that works out a lot of times. So do it yourself and either verify what I'm doing or show me, or show yourself at least, that you're right and I'm wrong. But anyhow, this will be just 1 over s e to the k minus t evaluated from 0 to a. And I don't know that I want to go on with it because the rest of it is very straightforward. Evaluated 0, you get just e to the k. Yeah, and actually, yeah, let's do what I thought about doing a few minutes ago and then didn't think to do because I got hung up on the signs. First of all, the e to the ks, this is e to the ks times e to the negative ts. And e to the ks is independent of t, it's constant, so it can come out in front of the integral. So I can say that we have the integral of e, we have e to the ks. Now remember that k is a negative number because of what I said here. But anyhow, we have an e to the ks, and then it's multiplied by just the integral of e to the negative ts dt, which we know to give us negative 1 over s as the lower limit, and I'm going to use the positive at the lower limit and negative at the upper limit, and I'm doing it in my head. I don't want to write it out. Write it out yourself. I think what we end up with here is 1 over s multiplied by 1 minus e to the as. Now I could have my sign wrong here. It might have to be a negative. So work it out, write it out. I'm not going to do the arithmetic because there's a good chance I do it wrong anyway, in my head or otherwise. So there it is. The procedure's the same as before. What you have to do is you got to find your function for the first period, and you got to do that integral. And you just do the integral right, and then you divide by your 1 minus e to the negative as. And it should be e to the negative as. And look here, you're going to have one here, you're going to have one here. Whether this is plus or minus, that's going to divide out, and everything's going to look good. Okay, so your L of f of t is going to be all this divided by this. And you're also going to have a 1 minus e to the negative as here. I could write that as one minus e to the negative as over s multiplied by that takes care of all this, multiplied by e to the ks plus 1, or something like that. The 1 minus e to the negative as, I believe, is going to divide out. And that can be made sense of in terms of the picture and so forth, but no room to write things out, so that's my excuse. I'm not going to do that. But there's another example.